Okay, in this lesson we're going to be starting this whole chapter on polynomials. We'll be doing a lot with polynomials, so it's important to have some basic understanding of some different terminology and things that we'll be using throughout this chapter. So if you haven't done so already, you might want to pause this video to make sure that you get all these parts in your notes, because each of these parts that we're going to talk about are important terms that we'll be using consistently. So first of all, we're going to be looking at this example, this expression here, to define some of these different variables. First off, we would say that this polynomial is in the variable x because it's the only variable that's being used. When the polynomial is in only one variable, the largest exponent of the variable is the degree of the polynomial. So the fact that I have only x's here, to figure out the degree of the polynomial, I look at the largest exponent. In this case, the largest exponent is a 4. So I would say that this polynomial is in degree 4. The pieces separated by a plus or minus are called the terms. So this polynomial, we would say, has a total of, this would be 1, 2, 3, 4, 5 different terms there. When we count the terms, we're not just counting the terms with the variable. So if you notice, I have 1, 2, 3, 4 terms with an x, but this last term doesn't have a variable. That's still a term. So a term is not determined by whether or not it has a variable. A term is determined by being separated by a plus or minus symbol. A division sign or any other symbol will not separate terms. Terms are only separated by a plus or minus. Now it's important to understand that the standard form is when the terms are written in what we call descending order. So notice how my first term here has a degree of 4. Then it goes from 4 to 3 to 2 to 1 to no variable. That is standard form. So it's descending from the largest, so the variable with the largest exponent, all the way down to this case to not even having a variable at all. The numbers attached to the variables are called coefficients. So negative 0.001 would be a coefficient, 0.01 would be a coefficient, 0.06 is a coefficient, negative 0.564, because it's a minus here, so it would be a negative 0.564 is a coefficient. Those are my only coefficients. Negative 0.011 is something else. That's the number not attached to any variables. That's a constant. So this piece here is what we call a constant. All the other numbers in that polynomial are coefficients because they're attached to a variable. Now we have a very special coefficient, and that's what's called the leading coefficient. The leading coefficient is a coefficient. It's the number attached to the variable with the largest exponent. So wherever the degree is, here's the degree. So if the degree is 4, that means the leading coefficient is negative 0.001 in this case. So the leading coefficient is not the largest coefficient. The leading coefficient is the number attached to the variable with the degree, with the largest degree. So those are just some basics. You need to make sure you understand this idea of a constant, a leading coefficient. You need to know that standard form is when it's written from the largest exponent to the smallest or no exponent at all. You need to know the number of terms. All of this is important. You'll be asked this in your assignment. So for example, here in this problem they give us the polynomial x squared minus 16x to the fourth plus 3x squared plus 96, and they ask us to first list all the coefficients. Well, notice this little note I have over here to the right. It's important to always look to see if you can combine like terms before you get started. So like terms, so here's an x squared and a 3x squared. Those are like terms. So we can add those together. So if I wanted to write this in standard form, which we're going to do in part C, so let's go ahead and do that now. I would say it's negative 16x to the fourth. Now the 3x squared and the x squared, those get added together. This is just 1x squared plus a 3x squared, meaning I have 4x squareds. And then plus 96. So that would be your answer in standard form. And so when it says list all the coefficients would be negative 16 and 4. 96 is not a coefficient. 96 is a constant. They don't ask for that. Part B, they say what are the degree and leading coefficient? The degree, in this case, would be 4 because the largest exponent is 4. And the leading coefficient, I'll abbreviate as LC, the leading coefficient is the coefficient that's attached to that variable with the degree there of 4. So our leading coefficient is a negative 16. Okay, now we name different polynomials by the degree of the polynomial. And these are degrees 1 through 5. We have special names. Beyond that, we don't have to worry about it. In fact, even a quintic, we don't hear about that very often. But let's just talk about these for a second. So if it has a degree of 1, we've talked about those before. Those are linear equations. You just didn't know that we called that a degree of 1. We've talked about quadratics in the past. Quadratics are when the highest degree, when the degree is 2. A cubic function, well, that makes sense because cubed means that it's to the third power, so a cubic function means you have a degree of 3. Quartic, well, you know, a quarter is 4, so a quartic polynomial would be where the degree is 4, and a quintic polynomial is where there's a degree of 5. Let's look at these examples. Here we have a function 2x squared plus 3x plus 4. Function g is the function 5x cubed plus 1. In part A here it asks us to find what's f of x plus g of x. We're going to add these two functions together. So I'm going to take 2x squared plus 3x plus 4, and I'm going to add that to the other function, 5x cubed plus 1. We want to write your answer in standard form. The standard form for this, if I add together like terms, the 5x cubed, there's nothing to add that to, so it's just going to be a 5x cubed. The 2x squared, there's nothing to add that to, so that stays a 2x squared. The 3x, can't add anything to that, but the 4 and the 1, those are like terms, we can add those together, so it becomes just 5. So this would be, when I add these two polynomials together, I get 5x squared plus 2x, or 5x cubed, I'm sorry. 5x cubed plus 2x squared plus 3x plus 5. So the degree would be 3. Now let's try subtraction. Subtraction is a little trickier. If I had 2x squared plus 3x plus 4, I'm going to subtract from that the other function, 5x cubed plus 1. Now notice how I put this in parentheses. That's very important because this minus means that the 5x cubed and the 1 are going to be subtracted from the other polynomial. So one thing you could do is you could distribute that through. So that would become a negative 5x cubed. And this would become a negative 1, because now I'm subtracting the 5x cubed from the polynomial that's in red there for function f, and I'm subtracting the 1 from the other polynomial. So now when we combine these like terms and put it in standard form, I'm going to start out with a negative 5x cubed, because I can't subtract anything from it. The 2x squared is still positive. The 3x is still positive. But 4 minus 1 is 3, so it'll be plus 3. The degree for this is still 3. Now, let's look at the next section. It says without multiplying the polynomials, we don't want to actually multiply these together, but we want to figure out what the degree of the polynomial would be. Even though we don't have to multiply them completely, we have to think about what would happen here. If I were to multiply these two polynomials, I would be taking the 2x squared times the 5x cubed and the 2x squared times the 1. I'd take the 3x times the 5x cubed and the 3x times the 1. I would take the 4 times the 5x cubed and the 4 times the 1. But all they're asking me to do is figure out what the degree of that polynomial would be. I would get the degree by multiplying the largest term from this polynomial and the largest term from this polynomial. So I'd get the degree, so from 2x squared times 5x cubed, which would end up being 10x. Remember when we're multiplying and the bases are the same? Remember we add the exponents. So x squared times x cubed would be x to the 5th. So the degree of this would be 5 then. The leading coefficient, when we multiply these together, would be 10. So this next part summarizes what we just talked about here. It says when multiplying, so the degree of the product of two polynomials is the sum of the degrees of the polynomials. If you notice here, the degree of the first polynomial would be 2. The degree for the second polynomial would be 3. If I add those together, I get 5, and that's the degree when we multiply those together. So again, the degree of the product of two polynomials, when we're multiplying two polynomials together, the degree is going to be the sum of the degrees of the polynomials. The leading coefficient of the product of two polynomials is the product of the leading coefficient of the polynomials. So what that means is that if I wanted to find the leading coefficient for the product of these two polynomials, I would take the leading coefficient from this one, the leading coefficient from this one, which is 5, and 2 times 5, sure enough, gives us the leading coefficient of the product of those two. 2 times 5 is 10. I know that seems confusing, but it's really not meant to be that hard. So let's look at a different type of situation. This time we're going to look at composition of two functions. So it says here, write an unsimplified expression for f following g of x, meaning I'm going to put function g inside of function f. So I'm going to take this function and replace x with that function in function f there. So this is going to be, instead of 2 times x, it's going to be 2 times 5x cubed plus 1 being squared, plus 3 times x, but instead of x, it's going to be 5x cubed plus 1, and then plus 4. And it said to write an unsimplified, so that would be my answer for the first part. Now it says use it to find the degree of f following g of x. Now notice how I'm going to get the degree from this section. More specifically, I'm going to get the degree from the 5x cubed being squared. Remember, a power of a power postulate tells me that I would take these two and multiply them together. So I would take 3 times 2, which is 6. And we want to use this now to find the leading coefficient, is what that should say. We want to find the leading coefficient of f following g of x. Well, I would get the leading coefficient from this 5. Remember, this 5 is going to, before we multiply it by 2, we need to square it, and then it would get multiplied by 2. So 5 squared is 25, times 2 is 50. So the leading coefficient here would be 50. Because this 5x cubed, it would end up being squared. Now granted, all of that would be squared, but we're just focusing on the leading coefficient. So I don't have to worry about any of the other numbers, I just have to worry about the 5 there. So 5, when you square it, becomes 25, and then you multiply it times this 2 that's out in front here, and that's what gives you 50. So this kind of summarizes what we just did. So let's work on this one together. This asks us to find the degree of f of x times g of x. Remember, when we find the degree and we're multiplying two polynomials, we take the degree of the first polynomial and add it to the degree of the second polynomial. Notice how the degree here of the second polynomial is just a 1. So the degree here, I would add these two together. 2 plus 1 is 3. And to find the leading coefficient here, I would take this 3 times that 4. 3 times 4 is 12. Now they ask us to find the degree of f following g of x. Now they didn't talk about a shortcut to doing that, but let's look up here. Remember what we did is we took the degree of, when I took the 5x cubed and put it in this other function, we ended up taking 3 times 2. So when we're doing a composition of functions, instead of adding the degrees together, we're going to multiplying them, because 3 times 2 is 6. So I'm going to do the same thing here. I'm going to find the degree of this function, I would take the degree here of 2 times the degree of 1. 2 times 1 is 2. The leading coefficient of f following g of x, well, I'd be putting this 4 inside of here for x, so the 4 would end up getting squared. I'll just show you what I mean here. I'm taking the 3, the 4x minus 5, be put in there for x. Now granted, you'd have the rest of it, but we don't care about that, because we're going to focus just on this piece here, because that's where every degree would be. So the 4 would get squared. 4 squared is 16, and 16 times 3 is 48. So the leading coefficient here would be 48. I'll go ahead and skip the next section. I want to get to the end here. So let's go ahead and let's look at this example. So let's look at this. It says Anita Lone and her family start saving for college when she graduates from 8th grade. At the end of each summer, they deposit money into a savings plan with an annual percentage yield of 5.8%. Anita is planning to go to college in the fall following her graduation from high school. How much money will be in the account when she leaves for college if no other money is added or withdrawn? So let's look at this table. So it says at the end of summer after 8th grade. So in other words, right before going into 9th grade, they deposit $1,200 into her account. At the end of the summer after her 9th grade year, so in other words, right before going into 10th grade, they deposit $850 in her account. And so on, all the way up to right before she leaves for college, they give her $1,300. That $1,300 doesn't really sit in her savings account to earn any interest. It's just one last dollar amount that she gets. And if you remember talking about the compound interest formula, the amount is your principal times 1 plus, technically it's R over your rate divided by the number of times it's compounded. But if you remember, if it's compounded annually, it's just 1 plus R to the number of times it's compounded. Again, if it's compounded annually, it's just 1. And so your exponent would just be to the time. So this will be the formula that we're going to use to figure out how much each of these are going to earn over the course of the years, all the way up to that $1,300. So let's start with that amount after her 8th grade year. So it's going to be $1,200 times 1 plus the rate. The rate is 5.8%, or remember, we don't use percents the way they are. We change it to decimals, so it'd be 0.058. Well, if I add that to 1, it'd be 1.058. Now I have to figure out how long that's going to sit in her account. Remember, this is an amount that's received at the end of the summer, so right before her 9th grade year. So this is going to sit in there for all of her 9th grade year, her 10th grade year, her 11th grade year, and her 12th grade year. So it's going to sit in their account for 4 years before it's going to get withdrawn for college. Then after 9th grade, after the summer of her 9th grade year, they deposit $850 in that account. Same interest rate. So then it's going to sit in there for 3 years. And the 10th grade, after the summer of her 10th grade year, they're going to deposit $975. And then we'll do her 11th grade year would be $1,175. That's just going to sit in there for 1 year, so that's going to receive a little bit of interest. And remember, we said that $1,300 that's given to her right before she enters college, so it's not going to even have time to sit in her account, so it's not going to gain any interest. So we don't have to figure that in. It's just going to be just the plain old $1,300. Well, if you do that on your calculator, if you work that all out, you're going to get an answer of $6,144.74. That's how much she would have when she would go into college there. Okay, why don't you guys try this one on your own? So why don't you pause the video, and this one's very similar to the previous one, so it shouldn't be very difficult setting it up. Why don't you guys go ahead and try this one on your own? So like I said, pause the video and hit play when you're ready to check your answer. Okay, so let's see how you did here. So this time it says Anita degree, and her family starts saving for college when she graduates from 8th grade. At the end of each summer, they deposit money into a savings plan, this time with an annual percentage yield of 4.2%. Anita is planning to go to college in the fall following her graduation from high school. How much money will be in the account when she leaves for college if no other money is added or withdrawn? So again, she gets this at the end of the summer. Following her 8th grade year, she gets $2,000. So your principal would be $2,000 times 1 plus the rate. Again, we would take 0.042, so it would be 1.042, times the time. Again, this is going to sit in there for 4 full years, plus the next dollar amount, which would be $2,500, times 1.042. This would be cubed, plus 2,200 times 1.042. This would be squared, plus 2,050 times 1.042, and that's not going to have any exponent, so it just sits there for 1 year. And finally, We would add to that the 2100. When you do that on your calculator, what you should have gotten is $11,810, or if you rounded to $811, that would be fine because your cents would be 96 cents. So $11,810.96 would be your answer. So hopefully you have an understanding of the basic ideas here of polynomials. The most important parts are to make sure that you understand these terms that we talked about at the beginning, because you will see these throughout this entire chapter. So with that, good luck on your assignment.